Hello. In this video, we will be discussing the important preparation, properties, and main uses of this citric acid. We know that this citric acid occurs in juice of citrus fruits such as lemons, limes, guancals, and oranges. The lemon juice contains around 7 to 10 percentage of citric acid. This is the citric acid, that is CH2COH, COH, CH2COH. This is citric acid, and this IUPAC name of citric acid is 2-hydroxypropane 1,2,3 tricarboxylic acid. 1,2,3 tricarboxylic acid. So this is citric acid. Now let us consider what are the important method of preparation of this citric acid. The first method from glycerol. So here this glycerol is reacted with hydrochloric acid. First we get this one 1,3 dichlorohydrin. Then this on treatment with dilute nitric acid, and oxidation we get 1,3 dichloroacetone. This 1,3 dichloroacetone is reacted with hydrogen cyanide at the pH 9 to 10. Around the pH 9 to 10 we get an 1,3 dichloroacetone cyanohydrin. We get 1,3 dichloroacetone cyanohydrin. This on treatment with potassium cyanide followed by hydrolysis we get this one citric acid, that is CH2COH, COH, CH2COH. That is, this citric acid can be prepared from this glycerol by means of the sequence of this reaction. First reacted with HCl, then followed by the oxidation with this dilute nitric acid, then reacted with hydrogen cyanide and potassium cyanide, followed by this acidic hydrolysis. We get citric acid. Then second method, by Reformowski reaction. In this reaction, this ethyl diethyl oxaloacetate. This diethyl oxaloacetate reacted with this ethyl bromoacetate with zinc, followed by hydrolysis. We get citric acid. So here in this by Reformowski reaction, citric acid can be prepared by the following steps. That is, this citric acid can be prepared by this Reformowski reaction involving the condensation of this diethyl oxaloacetate with ethyl bromoacetate in process of an zinc, followed by hydrolysis. We get citric acid. Then another method from lemon juice. We know that lemon juice contains citric acid. Here how we can prepare this concentrated form of citric acid from this lemon juice. First, this lemon juice is boiled to coagulate the proteins which contain this juice. So first this lemon juice is boiled to coagulate proteins. Then it is decanted, and and again boil again, and then neutralized with this one calcium hydroxide, or neutralized with lime. Then when we neutralize with this lime, calcium hydroxide, we get an insoluble calcium citrate precipitate. This calcium citrate is this calcium citrate is decomposed with the help of dilute sulfuric acid, we get calcium sulfate as calcium sulfate is in the form of precipitate, and the we get this calcium sulfate. We get this calcium sulfate as precipitate form, and in the filtrate containing that filtrate contain this citric acid. After this filtration, this filtrate is concentrated and cooled to get crystals of citric acid monohydrate. So from lemon juice also we can prepare this one, citric acid. First one, this lemon juice is boiled to coagulate proteins, then decanted and boiled again, and then neutralized with this calcium hydroxide lime. Then calcium citrate, which is insoluble in boiling water, precipitate out. This is collected by filtration, and it is then decomposed with dilute sulfuric acid. This calcium sulfate is calcium sulfate precipitated, and it is filtered off. This filtrate is concentrated and cooled to get crystals of citric acid monohydrate. Then next, what are the important chemical properties of this citric acid? First one, acidic character. This acidic character of citric acid can be explained by the reaction with bases. When we react this citric acid with bases, it form a series of salts. When citric acid is reacted with sodium hydroxide, first it will form monosodium citrate, then disodium citrate, and finally it will form trisodium citrate. Similarly, when next reaction is action with alcohol. When this citric acid is reacted with alcohol, we get trialkyl citrate. This alkyl group depends upon the alcohol. So citric acid undergo reaction with this alcohol, we get trialkyl citrate. Then next one, acylation. When the citric acid is reacted with acyl chloride, CH3COCl, in presence of a base pyridine, we get acetyl citric acid. These are simple reactions. Then next one, reduction. When citric acid is reacted with concentrated hydrogen iodide, it reduces to propane 1,2,3 tricarboxylic acid. It reduces to propane 1,2,3 tricarboxylic acid and iodine. Next one, action of heat. Here, citric acid is heated in presence of concentrated H2SO4 or heated alone. This citric acid undergoes dehydration to get this aconitic acid, which on further heating, this aconitic acid loses carbon dioxide. And we get a mixture of isomeric unsaturated acids, citraconic acid and itaconic acid, which on further heating we get the anhydrates of corresponding acid, that is citraconic anhydrate and itaconic anhydrate. So action of heat means when citric acid is heated alone or heated in presence of sulfuric acid, it first action of heat means when citric acid is heated alone or heated in presence of concentrated sulfuric acid, first it form aconitic acid, Then further heating yields a mixture of isomeric unsaturated acids like citraconic acid and itaconic acid, which on further heating it will result the anhydrates of these acids, that is citraconic anhydride and itaconic anhydride. Then last one, action of fuming sulfuric acid. Action of fuming sulfuric acid. When the citric acid is heated with fuming sulfuric acid or oleum, H2S2O7, we get acetone dicarboxylic acid. We get acetone dicarboxylic acid. Acetone dicarboxylic acid. So these are the important properties of this citric acid. The next one, important uses of citric acid. Citric acid is used as a flavoring agent and preservative in foods and beverages. So all we know that this thing, that is citric acid is used as a flavoring agent and preservative in foods and beverages, as an emulsifying agent in ice cream. Then it is used as an acidulant in cosmetic creams, gels, shampoos, and this one liquids. Then as an active ingredient in some bathroom and kitchen cleansing solutions. Then it is used as a mordant in dyeing and printing. It is also used in the preparation of Benedict solution. It is a reagent which is used to analyze the presence of, which is used to determine the presence of carbohydrate. Carbohydrate and aldehydes. Similarly, this citric acid is used in the form of its salt to deliver those minerals in a biologically available form in many dietary supplements. Similarly, citric acid is also used in the these esters of citric acid are used as solvents in plastic industry. So these are the major, these are the important uses of citric acid. So here in this video we will be we already discussed about citric acid, methods of preparation of citric acid, similarly properties of citric acid, and important uses of citric acid.